Welcome back to this lesson series in Factorizing Quadratics. Today we'll be looking at how do we factorize harder quadratics. If you haven't already, I highly recommend that you look at Factorizing Quadratics 1 because I'll be talking about this ax squared plus bx plus c generic form of a quadratic quite a lot today, and if you haven't seen that or if you don't know about this, you definitely need to. So if you haven't already, please watch the first lesson in this series. But today, as just mentioned, we'll be looking at how do we factorize harder quadratics. And why are they called harder quadratics? Well, they're called harder quadratics because it's for when a is greater than 1, okay? And if we refer back to what a means, a is the coefficient, okay? And we learned that word in the first lesson. This is the coefficient, which is a fancy way to say the number in front of x squared. So the number in front of x squared, which we refer to as a, if that is bigger than 1, we refer to these as harder quadratics because the method in which we factorize them isn't the same as the one where it is just x squared, where a is 1. When you've just got x squared, we can use the method that we saw in lesson 1. When you've got something that's bigger than 1, you have to use the following method. So all that means, if you look at example 1, all it means is that we have a 2 in front of the x squared instead of x squared plus 7x plus 5. If we had this, we would just have to use the method from last lesson, but when you have a 2, or if you look at example 2, we've got 3 or even 7. When that number in front of x squared, or what we call a, is bigger than 1, we're going to have to use the following method. So let's just sort of preface on why do we need to use that method. So we're going to take this example 1, and I don't want you to write this, okay? You do not write this. We're just going to explore why we need another method. Okay, so if we explore why do we need another method, so if we take example 1 and just see, if we try to do the method from last lesson on this, what would happen? So if we recall, the first thing that we need to do for the previous method is you take c, which in this case is 5, and you list the factors of it. So what are the factors of 5? Well, how do you make 5? 1 and 5, or minus 1 and minus 5, because recall that two negatives multiplied together make a positive. And remember, we're looking for two factors of c, which is this 5, that add to make b. Okay, and as I said earlier, I'll be referring to these a, b, and c numbers, or integers. We're looking for two of our factors that add to make 7. Well, 5 is a prime number, so the only thing that makes 5 is 5 and 1, or minus 1 and minus 5, because two negatives make a positive. None of those add to make 7. So that method that we learned last lesson does not work here. Okay. The reason being is, if we look at this, last lesson, we were putting x and x in here, because remember, x times x is x squared. Now, we don't have x squared here. We have 2x squared. What is the only way we can make 2x squared? It would be 2x multiplied by x. That would give me 2x squared. Okay? So this coefficient a of the x squared is the issue. So as you can see, the method from last lesson does not work. So we're going to have to find a different method. And that takes us on to today's lesson. How do we deal with a coefficient of a, or a coefficient of x squared, which we refer to as a, that is bigger than 1? Well, the first thing that you need to do is you take a, which in this case is 2, you take c, which in this case is 5, and the first thing we're going to do is multiply them together. Okay, we're going to multiply a and c together. Well, what is a times c? Well, in this case, it is 2 multiplied by plus 5, which gives me 10. Okay, so 2 times 5 is 10. Now we use the same method, or an element of the method from last lesson, where we're going to list the factors of 10. So instead of listing the factors of c, for these coefficient of a where it is more than 1, we have to times a and c together, and then we're going to list the factors of that. So what are our factors of 10? What makes 10? Well, 1 and 10 makes 10. What else makes 10? 2 and 5. And from here, I could list minus 1 and minus 10 and minus 2 and minus 5 because they also make 10, but I can already see that my entire quadratic is positive. So I'm probably only going to need positive numbers here. What we're looking for is two factors, as we did in the last method, that add to make b. So can you see any factors that add to make b? Well, 2 and 5. 2 and 5 add to make b. So, where do we go from there? We found our factors. We've taken a, we've taken c, we've multiplied it together, which is 10. We've listed the factors of 10, and we found the ones that make b, which in this case is 7. What you're going to do at this point is you're going to rewrite the entire quadratic, but we're going to replace b with our new factors. So 2 add 5 makes 7, and we need an x as well. So we're going to say 2x squared plus, now I'm going to replace this 7x with this 2 plus 5. So that will be 2x plus 5x, and then I've got the plus 5 on the end. So if I put some colour on this, hopefully you can follow what's going on. We've kept a and c, yeah, the original a and c, and we've just changed this 7 into the two factors that make 7, but also multiplied together to make 10. So you got to imagine this as pulling it apart. We're pulling apart this quadratic by making sure that we have the factors of a times c, which in this case is 10, but also add to make b, and then we're writing them out. Okay. Where do we go from there? Well, from there we will split it down the middle. Okay, we're going to split that right down the middle, and we're now going to factorize each side. Okay, we are going to factorize each side. Well, if I focus on the left-hand side, what would the left-hand side factorize to? Well, here you need to know basic factorizing. Look at your two terms. We've got 2x squared plus 2x. What goes into both of those? Well, definitely a 2 is a factor, and also an x, because this has got an x squared and this has got an x. Remember, x squared is x times x is just x. What's the most amount of x's I can take out? Well, just 1, because this has got 2, but this one's only got 1. So the most I could take out of both is 1. So I can factor out 2x. Now you need to work backwards. What would I times 2x by to get 2x squared? Well, that would be x. What would I times 2x by to get 2x? Well, clearly plus 1. And that's that side factorized. Now we need to factorize the right hand side. Here is the tip. We need to make sure that these two brackets are the same. So once you've found out what this bracket is, because we know they need to be the same, we're just going to bang that straight into this one. Okay, we already know that these need to be the same, so we're just going to smack that straight into the other one, and then use logic to work out what would have to be on the outside to multiply to give us this. What would that be? What do I times x by to get 5x? 5. Check if it works. What's 5 times 1? Plus 5. So that's perfect. And it feels like a lot's going on. There's a lot of different elements to this. But the more you do this, the easier it becomes. And I'm going to re-explain every step after we finish this example 1. We're done now. We can say, therefore, my 2 brackets when I factorized it, one of them is going to be x plus 1. It's going to be this one here that we have the same. That is definitely one of our factors. The other one is going to be what's left over. So what is left over is these factors here, the 2x and the 5. So 2x plus 5 is in the other bracket. We've now completed the factorizing and we can check if it works. Okay, we can check if I expand this, I should get 2x squared plus 7x plus 5. So let's check. 2 times x, 2x times x, sorry, is 2x squared. 2x times 1 is plus 1x. 5 times x is plus 5x. 5 times 1 is plus 5. Now, we know, don't we, that that can be simplified. So 1x, sorry, that should be 2x. 2x plus 5x is 2x squared plus 7x plus 5. And as you can see, that is exactly the same as what we started with. So, looks like quite a complicated method. Each step is quite simple. I'm just going to go back through the steps and maybe we'll write on the side what happened. Okay, what happened with these steps? Well, step 1, we did a times c, okay, and that gave us this. We did a times c. Step 2, find factors of AC. Yeah, we find the factors of a times c. A times c is this, and we're going to find the factors of it. Once we found the factors, you said, right, which ones add to make b? Find the factors of AC that add to make b. That add to make b. Okay. And remember, when I'm saying A, B, and C, this is A, this is B, and this is C. Once we did that, we rewrite the quadratic with the new b. Yeah, we replace b, the 7x, we replace with the 2x plus 5x. Now, there's a really important point here. I could have written 5x there and 2x there, because remember, 2x plus 5x and 5x plus 2x is exactly the same result. Okay, you get the same answer. Now, you need to make a educated, logical decision there. I'm splitting this down the middle. It is much better for me to put the 2x here rather than here. Why is that? Well, what do we do in this step? We factorized. Is this 2 and this 2 go together nicely? Whereas if I put the 5 there, it's not as nice to factorize. And as you can see, this 5 goes very nicely with this 5. So when you go to rewrite out this step here, just make a decision. Which number goes nicer with the A and which number goes nicer with the C? Usually one goes better with the other. Sometimes they're both just horrible and there is no common factor of them, so it doesn't matter. But in this case, this 2 went much better with this 2 here, so I'm going to write that first. And this 5 went much better with this 5 here, which is the C. So I put it in that order. But I could have put it the other way around. It would have just made it slightly more difficult. From there, you split it down the middle and you factorized. Okay? And you need to make sure, so 4, split and factorize. 5, make sure both brackets are the same. And then you're done. So once you factorize the left side, as you saw, the little trick I did, I knew they need to be the same, so I put the same thing in there and then worked it out backwards. Once you've done that, and you've got 2 brackets that are the same with some leftover factors, they are what make our final answer. Okay, so looks like a bit of a mad method. There is logic to it. In my opinion, it's quite organised. And the more you practice it, the easier it will become. But just remember, this works for when A is bigger than 1. So 2, 3, 4, 5. Anything that's more than 1 is when this method is appropriate. So let's have a look at example 2. Example 2 says factorize 3x, that should say squared, so you can add that, 3x squared plus 13x plus 4. Well, what do? The method states that we take A and we take C, and we're going to multiply it together. Okay, we're going to take A, we're going to take C, and we're going to multiply it. So 3 times 4 is 12. Then we're going to list the factors of 12. What makes 12? Well, again, you can have 2 negatives or 2 positives to make a positive 12. But if I look at my quadratic, they're all positive. Everything is positive. So I'm only going to focus on the positive factors. What makes 12? 1 and 12. And 3 and 4. And 2 and 6. They are my factors of 12 in a positive fashion because it's all positive. I could have put -1, -12, -3, -4, -2, -6. But that's pointless because I'm trying to make a positive b. Remember, we're trying to find a factor that makes a positive 13. Okay, in this case, b is 13. Which one of these makes 13? Well, straight away, it's the 12 and the 1. Okay. Now, this is where you can make that decision. We're going to rewrite the quadratic, 3x squared. We get to make a decision now. Do I want to put the 1 with the 3 or with the 4? Do I want to put the 12 with the 3 or with the 4? It doesn't matter. 1 goes with any number, and 12, 4 is a factor of 12, and 3 is a factor of 12. So in this instance, there is no preferred order. It makes no difference. So let's just write plus 1x. Okay. Now I can write plus x, or I could write plus 1x for this. Remember, we need the x because we're trying to make 13x, not 13. I'm just going to write plus 1x so it's clear for you, but I would normally write plus x. Plus 12x plus 4. Okay, so remember, we keep in the a's and the c's as they were, and all we're doing at this stage is replacing the b with the 2 factors that we found. We're pulling apart this quadratic. Where do we go from there? Well, hopefully you can recall we're going to split it down the middle and we're going to factorize. So if I factorize the left side, what number can I take out of 3 and 1? Well, only 1, so nothing. Can't really take any number out. There's no point me writing 1 on the outside. X squared and x. The most I could take out is x. What would that leave me in the bracket? What would I times x by to get 3x squared? Well, that would be 3x. Okay, because x times 3x is 3x squared. What do I times x by to get 1x? Well, plus 1. Here's the tip. We know, hopefully, that this needs to be the same as this. So if that's the case, I can just take 3x plus 1 and fill it in there. Okay, that is going to save you lots of thinking about factorizing this. Now you just need to ask yourself, what would have to be on the outside when I expand this to get 12x plus 4? Well, what would you times 3x by to get 12x? 4. And check if it works. What's 4 times 1? 4. Brilliant. So it all works. We're done. We can say, therefore, my 2 brackets for my final factorized form is one of them is definitely going to be the 3x plus 1, because that's my repeated bracket. And the other one is going to be leftovers. So what do we have left over? X and 4. So x plus 4. How do I know it's a plus? Because it's just a positive integer, 4. So I'd write plus 4. That is us done. And again, you can, just to save time, I won't do it, but you can expand that out and see for yourself that you will actually get the original quadratic. So, is there anything that we need to talk about extra? I believe that's covered everything. Yeah, that's all good. So we're now just going to look at that method, and we're going to just repeat it on harder and harder examples. One where we've got negatives, one where we've got more negatives. And then right at the end, we're going to look at how do the examiners put these types of questions in other contexts. So how do they make it harder for you with some words and some pictures or some diagrams where you have to work it out yourself, where it's not just as straightforward as doing this. So we're going to go through these 3 examples here, and then we're going to look at the exam style questions. Okay. So example 3, we want to factorize 7t squared. It doesn't have to be x, it can be any letter. X is just an unknown. 7t squared plus 20t minus 3. What do we do first? We're going to take a. First of all, can I use this method? Yes, because a is bigger than 1. A is 7, so I can use this method. And we're going to take c. Now be careful here. C is minus 3. So I'm going to slow down a little bit for this one because it's our first negative. We're going to take them, we're going to multiply them. So we're going to do 7 multiplied by minus 3 would give me minus 21. Okay. So we've got minus 21. We need to list the factors of minus 21. So recall, how do we make a minus? Well, a negative times by a positive gives me a negative, and a positive times by a negative gives me a negative. Same thing, yeah? Just the opposite way around. That is going to be really important that you understand that. And that was put in the previous lessons worksheet. I've got a nice sort of diagram that you can look at, and it gives you all the different options. But a mixture makes a minus. So how do we make 21? We could have 1 and 21. But we would need 1 positive and 1 negative. So we could say minus 1 and positive 21, or 1 and minus 21. Because you need both options. Because both of them multiply together. Sorry, we need to get rid of that minus. 1 and minus 21. Both of those factors multiply to make minus 21. Okay? So, what else makes 21? Well, we could do 7 and 3. So we could see minus 3 and 7, or 3 and minus 7. Remember, what we're looking for, we're looking for 2 of these factors to add to make b, which in this case is plus 20. Well, what is minus 1 plus 21? Plus 20. So I actually did it on the first factor that I listed. But I always recommend, when you're learning, write all your factors down, just so you've got them, and then you'll see which ones. And the more you do it, you'll realise, I don't need to write these 3 and 7 because it's never going to make 20. Okay, you'll get a lot better at it. Where do we go from there? Well, we will write down our quadratic, and we're going to replace b with minus 1 and 21. Now, here is a situation where we can decide what we want to put where. 21 goes with 3 and 7. So it makes no difference. 1 goes with both, so it makes no difference. I'm going to write minus 1x plus 21x minus 3. So remember, the 7t squared, the a and the c have stayed the same. All we've done is rewritten b as the 2 factors that we found. And I had to put an x on it because b is, I don't know why I've put an x there. That should be a t. Apologies. That should be a t. Yeah, I'm so used to writing x, and you're probably the same, that when it's not x, I write it anyway. This t needs to be there because b has got a t on it. Now, if you think about what happens here, if I just add those together, I'm going to get the original plus 20. So I haven't actually done anything at this point. I've just manipulated this quadratic. Split it down the middle. We're going to factorize each side. So if we factorize the left side, well, the only factor of 1 and 7 is 1 because 7 is prime. but we have got a t, so we could take a t out, which would leave me 7t minus 1. 7t times t is 7t squared. T times minus 1 is minus 1t. Well, now we can use our trick where we know these brackets need to be the same, so I can just replace this with 7t minus 1. What would need to be on the outside to make this work? Well, what do I times 7t by to get 21t? 3. And check if it works. What's 3 times minus 1 minus 3? Brilliant. So we're done. We can say therefore, and if you don't know already, those 3 dots mean therefore. I've mentioned it in a few of my lesson series. That is a mathematical way to write therefore. And it makes sense in this case because we've done loads of stuff here, and then we're saying therefore our 2 factorized answers are going to be 7t minus 1 and t plus 3. Okay, because one of the combined brackets is one of them and the leftovers is the other. Now, a lot of students will ask, does it matter which way round I put these brackets? No, you could put t plus 3 and 7t minus 1. It's the same thing, they're both correct. I always just put the bigger coefficient of t first, so I'd always have 7t here and t there, just because it looks nicer in my opinion. But either way is absolutely fine. So now we've got an example where we've got 5p squared minus 13p minus 6. Here, we've got 2 negatives. There's no positives here apart from the coefficient of p squared. A is positive, but b and c are negative. But the same method applies. You just need to be careful with your positive and negative numbers. So we're going to take a and c and we're going to multiply it together. Okay, we're going to take a, which is 5, c, which is minus 6, and we're going to multiply them, so that would be minus 30. I'm going to list the factors of minus 30. Well, remember, 2 negative and a positive, a mixture makes a minus, so we could have minus 1 and 30, or 1 and minus 30. We could have 2 and you should check as you go along. It might be worth checking. What does that add to? That adds to 29. What does that add to? Minus 29. That is not 13. Remember, we're trying to make it minus 13. Okay, that's important. Minus 13. We could have minus 2 and 15, or 2 and minus 15. Okay, the opposite version. Now, do any of those make minus 13? Well, minus 2 add 15 would be 13, but we need minus 13, so that's not going to quite work. However, 2 minus 15 is minus 13, so we found it. It's this factor here. From here, we're going to take them and we're going to write them out inside our quadratic where we replace b. So let's see if I can not write x this time. 5p squared, that stays. Now, this is where you can use what I said to help us. We've got minus 15. Is 15 going to go better with 6 or with 5? Well, obviously 5, because 5 is a factor of 15. And look, 2 goes better with 6 because 2 is a factor of 6. If I wrote minus 15p plus 2p minus 6, that is a lot better than if I wrote 2p minus 15p minus 6, because if I split that down the middle, 5 and 2 don't have factors of each other and 15 and 6 do. Okay, so it's better if we do it the other way because they're both going to have common factors. So I would write here minus 15p, and again, it makes no difference if you did it the other way. You're still going to get the same answer. It's just not going to be as easy when you do the factorizing step. Plus 2p, and then minus 30. No, what was it? Minus 6 is c, sorry. Minus 6. So again, just to put some colour on here so it's obvious what happened. The a and the c stayed the same, and we've replaced a b with 2 factors of a times c that make b. if I split that down the middle and factorize. So hopefully what you're seeing at this point is it's the same method every single time. The only thing that changes is the numbers. So if you can get this method and the way that I'm laying it out in your memory and plenty of practice with it, you'll find this really easy because the only thing that's going to change are the numbers. What can we factorize out of 5p squared and 15p? Well, a 5 definitely, and a p. And I don't know if I mentioned this, but at this point, you want to be taking out the biggest thing possible. The absolute biggest factor of 5 and 15, and the biggest factor of p squared and p, which in this case is 5p. What would that leave me with? Well, 5p times p would give me 5p squared. 5p times minus 3 would give me 15. And once you get to this point, it's pretty much, you're at the finish line, it's almost done. We know that these brackets need to be the same. So that would be p minus 3. What would need to go on the outside to make this work? Well, 2. Because 2 times p is 2p and 2 times 3 is minus 3 is minus 6. So we're done. We can say, therefore, now which bracket would I put first? It doesn't matter. But because I've got 5p and 2 here, I like the 5p plus 2 first, and then the p minus 3. If you did it the other way around, it makes absolutely no difference. It's the correct and same answer. It just looks different. So that's that one done. That takes us on to the final basic example, which is example 5, where we have got 5y squared minus 13y minus 6. Okay, so the first thing we're going to do is multiply those together. That actually, is that the same? That is exactly the same numbers, just with different letters. So that's the same numbers with different letters, which means it would be a waste of our time doing that right now because we've got it all here. So what you could do is you could save that and maybe come back and have a go at it in a couple of days or in the future to see if you can replicate the method. But there's no point us going through this because it's exactly the same method here. Okay, it's just, as you can see, these, if I change those to y's, they're the same. So I've accidentally written the same question twice. So we won't worry about example 5. If we go across, this would bring us on to some exam questions now. So these types of questions here, example 6 and example 7, are going to be the type of thing that you would see in an exam. So, you know, past the middle of the exam, these are the types of things that they could put in. So let's have a read. The rectangle ABCD has a area of 2x squared plus x minus 3. Find an expression for its length and width. So we want its length and we want its width. Okay. So how are we going to map this together? Well, the best way you can approach these questions is break it, because it looks really difficult. You've got some horrible looking quadratic. They're talking about area and they want the length and the width. But if you break it down to its most basic key words, we've got a rectangle and we've got an area. Well, what do we know about a rectangle and its area? We know that the area of a rectangle, okay, the area of a rectangle is base times height. Okay, we know that, don't we? So we could say that this is the base and this is the height. So all I've done there, the really good exams technique, is I've read the word rectangle and area and just thought as basic as possible. Instead of getting overwhelmed by this stuff here, I've just thought, right, what's the most basic thing in this question? Area and rectangle, write it down. The area is base times height, label my base and my height. Well, what have they told us? They've told us that the area of this is 2x squared plus x minus 3. So the area inside here is 2x squared plus x minus 3. And this is just where you need to now piece this together. We've written our basic formula because we knew it was a rectangle and we knew its area. We've labelled it, and now we've realised that the area inside is in fact a quadratic. Now, if we bring this all back together, what would this b and this h have to be to multiply together to get a quadratic? Well, it would have to be two brackets. It would have to be. It would have to be a bracket here with something in it. It would be like x plus something, and 2x plus something here because you've got 2x squared. So we need two brackets that multiply together to give me this. So the goal of this question is, we need to know what are these two brackets that multiply to give me 2x squared plus x minus 3. What are these two brackets that multiply to give me the area that they told us? Well, how are we going to do that? We could factorize. If we factorize this quadratic, what are we going to get? We're going to get two brackets. And those two brackets, when multiplied together, will give you what we factorized. So that's the key to unlocking this question. Here, this is basically asking us to factorize this quadratic. So I'm just going to take this here and just move it so we've got some space. So we're going to take the quadratic, which is 2x squared plus x minus 3, and we're going to do our technique on it. Okay, we're going to take a and we're going to take c, and we're going to multiply those two things together. Okay, and if we do that, we've got 2 times minus 3, which gives us minus 6. And then we're going to find the factors of minus 6 to add to make b. Well, what is b? Now, b, it doesn't look like there's a b. We've got an a, which is 2. We've got a c, which is minus 3. What is b? Well, you have to remember, what does x mean? X means 1x. So if I put a 1 in there, okay, if I put a 1 in front of the x, that's what it wants, 1x. b is 1x. Okay. So I need two factors that multiply together to make minus 6 and add together to make 1. Well, this is just what we've been doing in previous examples. What are my factors of minus 6? We could have minus 1 and 6, or 1 and minus 6 because a mixture makes a minus. We could have minus 2 and 3, or 2 and minus 3. Which one of those adds to make 1? Well, minus 1 and 6 is not 1. 1 and minus 6 is minus 5, so that's not 1. Minus 2 add 3. What's that? That's 1. So we found it. So it is minus 2 add 3. If I rewrite out my quadratic, I will get 2x squared. Now again, make a decision. Look, this 2 goes much better with this 2, and this 3 goes nicely with this 3. So I'm going to write the minus 2x first, then the plus 3x, and then the minus 3. So again, what's happened? A has stayed the same, C has stayed the same. I've just replaced B with the factors that we found. Now we're going to split this down the middle, and we're going to factorize each half. If I factorize each half, I can take out what from this? Well, if I focus in on this, I've got a 2 and a 2, so I can definitely take a 2 out. I've got an x squared and an x, so I can take an x out. What would that leave me in the bracket? Well, it would leave me an x and a minus 1, because 2 times x is 2x squared, 2 times minus 1 is minus 2x. I can now use the technique where we know these brackets will be equal, the same, so I can just write in minus 1 there. What would need to be on the outside of this bracket to make this true? What would you times x by to get 3x? Well, 3. What would you times 1 by, minus 1 by, to get minus 3? 3. So 3 is what we can put here. So our leftovers are going to be the 2x and the 3. So my two brackets from this question, I can say therefore 2x plus 3 and x minus 1. Okay, so that is us done, because if we think about this now, I could go and fill my base in over here as 2x plus 3, and I could fill my height in as x minus 1. Okay. And if I multiply those together, if I've got b and I've got h, if I multiply those together, if I multiply 2x plus 3 and x minus 1, guess what we're going to get? We're going to get this quadratic, because that's what we factorized. So we now have an expression for its length and for its width, or I've called it base and height, which is the same thing. So that is an example where you can use factorizing a harder quadratic inside of a much larger context question. It doesn't just give you a quadratic and say factorize it. It gives you a rectangle with an area that is a quadratic, and you have to make that link that to find out the base and the height, it's asking me to basically factorize a quadratic. And this is why the new GCSE can be difficult, because it doesn't tell you to do stuff, it wants you to work out what you have to do before you then go and do the method. Okay, so hopefully my explanation there made that quite clear, that breaking down the keywords, the most basic keywords in the question, can help you unlock what you need to do. So that will take us on to example 7, which again is one that you have to think about. Okay. So here it says a quadratic expression 3x squared plus ax plus 10 can be factorized. So they've told us that you can actually factorize it. Find all the possible values for a, positive or negative. Okay, positive or negative. So what's that asking us to do? It's asking us to work out what this a is, which we usually call b, don't we? We've got ax squared plus bx plus c. So we need to know, what could this be given a and c? Well, there could be loads of options, because what we've seen here, if we just take this example, if you didn't know what this was, if you didn't know what b was, which in this case is 1, these are all of our options that add to make b. Yeah? Because what were we doing? Here, we were trying to find a factor pair that specifically makes 1. But if we don't know it needs to make 1, then surely any of these options could be put here, which is correct. If you don't know what this b needs to be, any of these factors that make a and c multiplied together would fit in and be b. All of them would, because if they come from multiplying a and c together, then clearly they could actually be b. So this example could actually be argued as easier than factorizing if you understand how it all works. Only if you understand how it works. So what we're going to do? Well, we've got 3x squared plus ax plus 10. Now, we want to multiply a and c together, which is going to give me 30. Okay. Now, if we list the factors of 30, what makes 30? Now, in this situation, we need to list every single possible factor pair that makes 30, because then we can have all the possible values that could add together to make this a. 1 and 30, 2 and 15, 3 and 10, 5 and 6. What else makes a positive 30? Well, all of these, positive and negative, will make 30. So we could also have the negative versions, negative 1 and 30, negative 30, negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6. These will add together, multiply together to make 30, but all of these things add together to make different b values, or in this case a. So all of these options work and could be a possible value for this a. So we need to list out what are all of our values. And how do we do that? Well, remember, it's from these being added together. All of these things here will add together to make a possible b, which in this case they've called a. So what are my values? What are my possible values for, so we can say possible values for A equal, and now we just need to go through and check what these create. This would be 31. This would be 17, because remember we're adding them. This would be 13, and this would be 11. And then over here, minus 1 minus 30 is minus 31, minus 17, and you can see a pattern here, minus 13, and minus 11. So they are all of our possible values that could be A, because all of these options here multiply together to make 30, which means that it fits our A and C criteria, but they all add together to give you a different answer, which means there's there's 8 options of A there. What's the best way you can write this? Well, we've got 30 and minus 31. We could just write this, instead of writing them all out, we could just put plus and minus 31. Yeah? That just means you can have the plus or the minus version, which is what we're saying here, the plus or the minus version. We could have the plus or the minus version of 17. We could have the plus or minus version of 13, and we could have the plus or minus version of 11. That's a nice mathematical way to write 11 and minus 11. What's the point of writing that when I can write this? It means the same thing. Okay. And I might just make that note there for you, just to finish. So this basically means 31 or minus 31. Okay, so quite a lot going on there. Busy lesson. Hopefully those of you that found the first few examples quite straightforward really got your head around example 6 and example 7. They are difficult examples. They're quite easy to follow once you understand and once you can see someone doing it, like myself. But when you're sat there trying to do it on your own, it can be very tricky. So the only way that you can combat that is by making sure that you are really solid on the workings of quadratics. So if you found any of that tricky, go back and watch Quadratics 1, because that will take you through the basic quadratics. Hopefully you learned something there. Thank you for joining in. Next, we will be looking at completing the square, and we'll start to look at how can we solve these quadratics? Okay, and what do they look like on a graph? So there's a lot involved. Quadratics is a big topic. This is just the surface of them. There's so much more, and we'll be looking at those in future lessons. So thank you for joining in, and I will see you in the next one.